today I want us to look at something else. I want us to look at the poles. Look at the North Pole. It's the North Pole where we have this pink spot. Now, when the Earth is in this position, what do you notice on the North Pole, this pink spot? What do you notice?
I noticed that the sunlight doesn't reach the North Pole.
Exactly. So we see that here in the North Pole, when the Earth is in this position, there is no light at all. They are always in the dark here, this position. Now, still observe this North Pole. When the Earth is here in this position, what do you notice? The North Pole here. What do you notice?
I noticed that the sunlight reaches the North Pole.
You can see here in this position, they are always in the light. Always in the light. Imagine living in a place where at least on one day in the year, the sun does not go down. For 24 hours, we have sunlight. And as we said before, when the Earth is in this position, notice that they are always in the dark. Imagine living in a place like that, where at least one day in the year, the sun does not rise at all. For 24 hours, they have complete darkness. Imagine living in a place like that. Now, I want you to focus on the South Pole this time around rather than the North Pole. Now look at the South Pole. When the Earth is in this position, what do you notice here at the South Pole?
I noticed that the sunlight reaches the South Pole.
Exactly. See that they are always in the daytime. The sun does not go down. Imagine living in a place like that, where at least one day in the year, the sun does not go down. They are always in the day, 24 hours. Now, when the Earth is in this position, still pay attention to this South Pole. What do you notice when the sun is in this position?
I noticed that the sunlight doesn't reach the South Pole.
Exactly. Here. So you can imagine living in a place like that, where at least one day in the year, the people don't have any daylight at all. For 24 hours, they are in darkness. Now, this happens because the Earth is on a tilt. If the Earth were straight up and down as it rotates, this would never happen. But as a result of the tilt of the Earth, we have this phenomenon where at least one day in a year, in some parts of the world, in the North Pole, they don't have any sunlight or any daylight once in a year, all because the Earth is on a tilt. If one were to connect all of the places where at least one day of the year the sun never rises or never sets, you will get a couple of imaginary lines. Here in the North Pole is one of those lines. If you check here, on some globes, you will see that, it's actually dotted. So this imaginary line here is called the Arctic Circle. It marks off where at least one day out of the year the sun never rises or never sets. If you look at the South Pole, you can see the other imaginary line right at the South Pole, and it's called Atlantic Circle. If you check right at the South Pole, you will see the same kind of line, and it's called Atlantic Circle. So those imaginary lines mark off places on the earth where at least one day out of a year the sun never rises or never sets. And you know what? Those places have a special name. I want you to figure that out. Have you tried to figure that out? Those places are called lands of the midnight sun. Lands of the midnight sun. Those are the places at least once in the year or in a year the sun never rises or never sets. So you can now carry out your own research and find out those countries where we have such phenomena. As I said, lands of the midnight sun. What are the countries that make up lands of the midnight sun? So do your research and let's see what you come up with. Now this chart gives us the same idea as we saw when we used our globe and light. Here we have the winter solstice, where the people that live here have their longest night and their shortest day. But then the earth continues to move around the sun. As it's moving around, the nights are getting a bit longer and the days are getting shorter. The nights are getting shorter and the days are getting longer until the earth gets to this position where we have about the same number of hours for day and night. We have spring equinox. Equi means equal, nox means night. So here we have spring equinox, equal day and equal night. As the earth continues to move around the sun, the days keep on getting longer, the nights get shorter, the days get longer, the nights get shorter, the days get longer, the nights get shorter. Till here we have, for people in the northern hemisphere, we have the longest day and the shortest night, summer solstice. And then the earth keeps on moving around the sun. Now the days begin to get shorter and the nights begin to get longer. Days begin to get shorter and the nights begin to get longer. We get to this point where we have equal hours of daytime and night time. We have what we call the autumn equinox. As I said, equi means equal, nox means night. So we have the autumn equinox, and then the earth keeps on going around the sun, revolving around the sun. The days are getting shorter, the nights are getting longer. The days are getting shorter, the nights are getting longer, until we get to this position, winter solstice, when for the people in the northern hemisphere, they have their longest night and their shortest day. And it takes 1 year, 1 full year, for the earth to make a complete rotation, to make a complete trip around the sun. It takes 1 year. Now there's something else I want us to observe here. Now look at these perpendicular rays. Here, when the earth is in this position, winter solstice, we find that you can see the perpendicular rays are here at the southern part, below the equator, and beyond this point, the perpendicular rays cannot go further, can't go further south. And now, look at here. When the Earth is in this position, spring equinox, we have the perpendicular rays falling from here. You can see the perpendicular rays are right at the equator. You can see at the spring equinox, the perpendicular rays are right at the equator. Now, as the Earth revolves around the sun, at here when it's at the summer solstice, we are these perpendicular rays. You can see the perpendicular rays are here. This is the northern part, and this is how far to the north the perpendicular rays can get to. The perpendicular rays cannot go beyond this point. Now, as the Earth keeps on going around the sun, at this position, autumn equinox, we are the perpendicular rays. They are right here at the equator. So let's see the same idea on a regular globe, where the perpendicular rays, imaginary lines marking off the furthest points beyond which the perpendicular rays cannot get to the south, and then the furthest point in the north beyond which the perpendicular rays cannot go to the north. So those imaginary lines have special names. So I want you to check a regular globe like I have here and find out those imaginary lines in the north and also in the southern part, which mark up the limit that the perpendicular rays can get to in the north and also in the south. So if you look at your globe carefully, those imaginary lines that marks up the limit beyond which the perpendicular rays cannot move further north, you find that it has a special name. What did you find out? I'm sure you got it. That line, that imaginary line, is called Tropic of Cancer. The Tropic of Cancer marks off a limit in the north. Beyond the Tropic of Cancer, the perpendicular rays cannot go further north. The same way, you check the northern part and find out the limit beyond which the perpendicular rays cannot go further south. I'm sure you've been able to find out that. And what is the name you figured out? Tropic of Capricorn. So, Tropic of Cancer in the north and Tropic of Capricorn in the south are the limits that mark off the areas beyond which the perpendicular rays cannot go further north or further south. Now you can see these dotted lines here. We are trying to show the same idea. So this is Tropic of Cancer. You see the perpendicular rays, and this is the furthest point towards the north that the perpendicular rays can get to. So Tropic of Cancer. You can see that it is 3.5 degrees north, 23.5 degrees north. That's why we have the Tropic of Cancer. Now let's look at this illustration here. You see the Tropic of Capricorn, and look at the perpendicular rays. The perpendicular rays cannot go further south beyond the Tropic of Capricorn. So this is the furthest point towards the south that the perpendicular rays can get to, Tropic of Capricorn. And is situated 23.5 degrees south, 23.5 degrees south of the equator, Tropic of Capricorn. And Tropic of Cancer is situated 23.5 degrees north of the equator. So these are the limits that mark off the areas that the perpendicular rays can get to. Perpendicular rays cannot go beyond the Tropic of Cancer in the north, cannot go below the Tropic of Capricorn in the south.